Good morning, students. Hello. Is it audible or not? Hello. এই সিহঁতে যেটো জয়েন কৰিছে না নাই গম পাইছো কিন্তু একো নকয় যে কিবা কথা আছে না So a very good morning to all of you. Am I audible to you or not? Kindly unmute yourself. All of you kindly unmute yourself, and am I audible to you? Hello. Am I audible to or you not? Good morning, students. Now is it audible? Kindly unmute yourself.
Yes, sir, you are audible, sir.
Is it
I am able to
audible?
hear you. Yes, sir, I am able to hear you, sir.
Okay. So this is your first class. Okay.
Yes, sir.
So this is your first class. So today I simply start the basics of matrices. Actually, I will take your topic linear algebra. Okay. I will take your topic linear algebra in your first sem. So today I will simply discuss about matrices. Those you have already got in your HS second year. Okay. So simply Okay, so simply, what do you mean by matrix? If I asked you, what do you mean by matrix? Then what is a matrix? Matrix means what? Is simply arrangement of some elements in rows and columns. Okay, arrangement of some elements in rows and columns. See here. Okay, so this is a matrix. So those horizontal elements are called rows. These are called rows, and those vertical elements are called what? Columns. So I think all of you already know. All of you already know what is a matrix. It is arrangement of elements in rows and columns. Okay, arrangement of elements in rows and columns. Okay, so see here, simply how many columns are there? 2 columns are there. And how many rows are there? 2 rows are there. Okay, 2 rows are there. Clear? So this is simply a matrix. It is arrangement of elements. So now we got different type of matrix. I think, what do you mean by order of a matrix? If a matrix has 3 rows and suppose 2 columns, then the order of the matrix is what? 3 by 2. So what it is given? A matrix having m rows and m columns is called a matrix of order m by n. Oh, okay. A matrix having m rows and n columns is called a matrix of order m by n. It is read as m by n. That means if the matrix is 5 column, if the matrix has 5 rows and 3 columns, then its order is what? 5 by 3. Clear? Its order is 5 by 3. Now, what are the different type of matrices? What are the different type of matrices? Okay, see here. I think you already know what is a column matrix. Okay, see here. So different type of matrices. So what is first one? It is column matrix. Okay. So what is a column matrix? A matrix is said to be a column matrix if it has only one column. Okay. Then it is called a column matrix. Okay, see here. That means this matrix has how many columns? There is only one column. Clear? So therefore it is called a column matrix. Similarly, what is a row matrix? What is a row matrix? If a matrix has only one row, then the matrix is called a what? Row matrix. If it has only one column, then it is called column matrix. And if it has only one row, then it is called what? Row matrix. Clear? Now, case is what? Square matrix. Now, square matrix. So I think all of you know what is a square. Square means what? If length is equal to breadth, then it is called a what? Square. So same in case of what is a square matrix? What is a square matrix? That means if the number of rows are equal to the number of columns, then the matrix is called a square matrix. Okay, if the number of rows are equal to number of columns, then it is called a what? Square matrix. So this is an example. This is an example. So how many rows are there? 3 rows are there. And how many columns are there? 3 columns are there. Okay, so in case of square matrix, what happens? Since number of rows is equal to number of columns, so therefore what happened? Simply we can say that its order is suppose m or n. Since it is how many rows are there? 3 rows are there. And how many columns are there? 3 columns are there. So what is the order of the matrix? So order of the matrix is simply what? 3. Okay, so it is what? 3. So next it is what? Diagonal matrix. So I think all of you know what is diagonal. Okay, what is diagonal? So in case of in case of quadrilateral, all of you already know that what is a diagonal. Now what is a diagonal matrix? Okay, what is a diagonal matrix? So a square matrix is said to be diagonal matrix. A square matrix is said to be diagonal matrix if all its non-diagonal elements are zero. Okay, that means see here. So this is a square matrix, this is a square matrix, and this is your diagonal. Okay, so what happens? See, all the elements except the diagonal, all the elements except this diagonal are equal to what? Are equal to 0. Clear? So here what happened? The any elements of this diagonal may also be 0, no problem. Okay. So any elements of this diagonal may also be 0. There is no problem. But what happened? All the elements except the diagonal must be equal to what happened? Must be equal to 0. Okay. Then these are called what? Diagonal matrix. Then these are called diagonal matrix. So this is a diagonal matrix. Now, what is a scalar matrix? See here. What is a scalar matrix? So, what is a scalar matrix? See? So, a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. So, in the previous cases, you already got what is a diagonal matrix. So a diagonal matrix means you got where all the elements other than the diagonal are equal to 0. Those are called what? Diagonal matrix. Now what is a scalar matrix? Scalar matrix means what? If all the diagonal elements are what? If all the diagonal elements are equal, that means same, then those matrix is called what? Then those matrix is called what? Scalar matrix. Here see, what are the diagonal elements? All the diagonal elements are what? Root over 3. So that's why it is a what? Scalar matrix. Rest all elements are equal to 0. Now identity matrix. See here. Okay. So what is the identity matrix? What is the identity matrix? Identity matrix means what? Actually, it is a square matrix in which the diagonal elements are equal to 1, rest all are equal to 0. See here, a square matrix in which elements in the diagonal are all 1. Okay. In which the elements in the diagonal are all 1 and rest are all 0 is called an identity matrix. Clear? So here what happens? See, these diagonal elements are equal to 1 and rest all elements are equal to what? All the rest elements are equal to 0. So that's why this is called a what? Identity matrix. Clear? This is called a identity matrix. That means if all the elements of the diagonal are equal to 1 and rest element are equal to 0, then the matrix is called what? Identity matrix. So these are some elements example of identity matrix. So this is identity matrix of order 1, this is identity matrix of order 2, and this is identity matrix of order 3. Actually, these identity matrix are generally represented by IN. Okay, we denoted identity matrix of order n by IN. Okay, this n represents the order of the matrix. Since it is an identity matrix of order 3, so it can be written as what? I3, that means. So now 0 matrix is there. 0 matrix means what? 0 matrix means if all the elements of a matrix are equal to 0, then the matrix is called what? A 0 matrix. If all the elements of a matrix are equal to 0, then the matrix is called 0 matrix. Okay. So actually, besides this, you will get again some more matrices. These are called triangular matrix. So later I will discuss about this. What is triangular matrix? There are some Hermitian matrix, skew Hermitian matrix. Okay. So later I will discuss about this. So now equality of matrix today is simply just a revised class of HS12, nothing else. Okay. So now what is equality of matrix? I think you already know what is equality of matrix. So when two matrices are said to be equal, if first thing is what? If the order of both the matrix must be same, order of the matrix must be same, and second thing is what? The corresponding elements of one matrix must be equal to the corresponding elements of the second matrix. Okay, that means each element of A is equal to the corresponding elements of B. Clear? So this is called a what? This is called a equality of matrices. So these some examples are given. Find the values of A, B, C, and D from the following equation. So this is a second order matrix. This is also a second order matrix. Since it is equal is given, that means this twice A plus B should be equal to 4. Again, A minus twice B is equal to -3, and 5C minus D equal to 11, and 4C plus thrice D equal to 24. So that means you got 4 equation. Okay, you got this 4 equation. Twice A plus B equal to 4, and A minus twice B equal to -3, and this is 5C minus D equal to 11, and 4C plus 3D equal to 12. So this is you got. Okay. So so after that, I will going to discuss about determinant, the simple concept. Before this, you have to know what is the inverse of a matrix. Okay. Inverse of a matrix. So at first you have to know what is inverse of a matrix. Clear? What is inverse of a matrix? Okay, so what is inverse of a matrix? At first, see, if A is a square matrix, if A is a square matrix of order M, and if there exists another matrix B of same order M such that AB equal to BA equal to I. Okay, if AB equal to BA equal to I, then what happened? This B is called the inverse matrix of A. Clear? If you got AB equal to BA equal to I, then B is called the inverse matrix of A. And it is denoted by what happened? It is denoted by A inverse. At the same time, see, listen. Same time here, what B is called the inverse of A. At the same time, you also can say that A is also the inverse of B. We can say this one also. A is also the inverse of B. Okay. So in that case, A is said to be invertible. So invertible means actually what happened if the inverse of a matrix exists. If the inverse of any matrix exists, then the matrix is called what? Invertible matrix. Okay, if the inverse of a matrix exists, then the matrix is called what? Invertible matrix. Okay, so we can find, actually we can find out the inverse of a matrix by so many methods. Once you got A inverse equal to 1 by determinant of A into adjoint of A. Okay, 1 by determinant of A into adjoint of A. One is this one. But here you have to use the elementary row transformation method. Okay, to find out the inverse of a matrix, we have to use elementary row transformation or elementary column transformation. See here. Simply see one example. Inverse of a inverse of a matrix by elementary operation. Okay, inverse of a matrix by elementary operation. At first you have to know what are the elementary operation. That means these are the three elementary operation. Okay, so what is the elementary operation? See here, first one is the interchange of any rows or two columns. Okay, that means we can interchange any two rows or any two columns. See here, this is a square matrix. So here what we have done, we interchange row 1 to row 2 and row 2 to row 1. This is row 1 and this is row 2. So now in place of row 1, we put what? Row 2. See here, what is row 2? Minus 1, root 3, 1. So here in place of row 1, we put minus 1, root 3, 1. Again, in place of row 2, we put what? In place of row 2, we put row 1. Okay, 1, 2, 1. So that means we interchange row 1 and row 2. Okay, so from here what you got, that means we can interchange any two rows or any two columns. So that's it. This is your first elementary transformation. Now second one, see here what we can. Second one, see the multiplication of the elements of any row or column by a non-zero number. Okay, that means what happened, we can multiply the elements of any row or column by any constant. Clear? Here see, this column 3 tends to 1 by 7, column 3. This is column 3. What are the elements of column 3? It is 1, 1. Okay, so we multiply the element of column 3 by 1 by 7. See here, 1 by 7 into 1. Again, this is also 1 by 7. Clear? So this is your second one. Now what is the third one? See here, the addition to the elements of any row or column. The addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by any non-zero number. That means main thing is what? we can change any row or column with the help of some other row. Okay, we can change any row or column with the help of some other row. Here, see here. In this case, see here, this row 2 is going to be changed with the help of what? Row 1. Row 2 is going to be changed with the help of what? Row 1. That means, see here, with the help of row 1. This is the matrix C. So here what happened? Row 2 tends to row 2 minus 2 row 1. Okay. Row 2 tends to row 2 minus 2 row 1. So row 2, this is 2 minus 1. It is minus 2 into R1. That means 2 minus 2 into 1. Result is equal to what? 0. Again minus 1 minus 2 into 2. That means minus 1 minus 4. Result is equal to what? Minus 5. Okay. So now by using these three elementary operation, we can find out the inverse of a square matrix. Okay. And always remember, inverse of a matrix exists only in case of a square matrix. Inverse of a matrix exists only in case of a square matrix. See one example here. See, very simple example. This one. By using elementary operation, find the inverse of the matrix. Okay. So by using elementary operation, find the inverse of the matrix. So what is this one? A equal to 1, 2 and 2 comma minus 1. Equal to 1, 2 and 2 comma minus 1. So we can write this one A equal to I into A. So where I is the identity matrix, and you already know that if you multiply any matrix with the identity matrix, the result is always the same matrix. Okay. So if you multiply any matrix with the identity matrix, the result is always the same matrix. So that's why what you can write, A equal to I into A. A equal to I into A. So this is the matrix A. This is the identity matrix 1, 0, 0, 1 and A. Okay. So first thing is what? You have to make this matrix as a what? Identity matrix. So here you have to make this element equal to 0. So we applying this operation. Row 2 tends to row 2 minus 2 row 1. Row 2 tends to row 2 minus 2 row 1. So see what will happen. This 2 minus 2 into 1, that means 2 minus 2, result is equal to 0. Again minus 1 minus 2 into 2, that means minus 4. So it will be what? Minus 5. So next what you can do, you can make this element equal to 1 by dividing by minus 5 or multiply by 1 by minus 5. Okay. So now see, applying row 2 tends to minus 1 by 5 row 2. So see here. So if you row 2 multiply by minus 1 by 5, then this element equal to 1. This one. If you multiply by minus 1 by 5, 0 into minus 1 by 5, it will be 0. Again, minus 5 into minus 1 by 5, it will be equal to 1. And minus 2 into minus 1 by 5, it will be 2 by 5. And 1 into minus 1 by 5, it will be minus 1 by 5. Okay, so it will be minus 1 by 5. So that means what you got, see here, what you got, 1, 2, 0, 1, this is 1, 2 by 5, and this is 0 minus 1 by 5. Okay, you got this 0, 0 minus 1 by 5. Now what is left? Now simply you have to make these elements 2 equal to 0. So how you can make this one equal to 0? By minus 2. Okay, so what we have done, simply row 1 tends to row 1 minus 2 row 2. So it means 2 minus 2 into 1. So 2 minus 2 result is equal to 0. So same operation you have to done here also. Clear? So after that, what you have got? Suppose this matrix is what? Inverse of A. That means A into B equal to, you got I. Hello? So times is already over. So today is just the introduction class. Kindly all of you give your attendance here. Okay, you can, all of you give. So all of you can give the attendance in the WhatsApp group also. Okay, all of you can give the attendance in the WhatsApp group also.
Okay, sir.
Clear? So today is simply
Yes, sir.
the introduction class. So next time onwards, I'll start properly. Okay, according to the syllabus, I will give you the whole syllabus. My course, mainly I'll take this topic, linear algebra. So from next class onwards, I'll start it properly. And for today, simply you give the attendance in the WhatsApp group. Okay, along with your name. Okay, then that's all for today.